Okay, keeping this template here. We had started, right, the last video we got through all these angles, like where these angles come from. Hopefully that makes sense. We dissected, kind of looking at two circles here. First, this 45 one, we split all these up into basically eighths, right? Split the circle into 8. And then the next one we split it up into 12 because we did every 30 degrees. So I'm going to go ahead and erase those. We have all our radians over here on the unit circle. Let's give myself a little bit more room over here. Okay. All right. Now to get what we're looking at is finding all the points now. Okay, I'll switch to blue. We have the 4 easy points: 1, 0, 0, 1, negative 1, 0, 0, negative 1. But how do you know what the coordinates are for this 45-degree angle here, right? I know the radius is 1. We talked about that because it's a unit circle. But how do we get the x and the y? So everywhere the 45-degree angle lines up, what we're looking at is this 45-degree special triangle over here. See, if I pictured a triangle right here, right? We have a 45 here and a 45 here and a 90. Okay, that's what's going on. But this radius is square root of 2. I need it to be 1. So with triangles, I know that the ratios remain the same, right? No matter if I shrink this down or if I enlarge it, right? The ratios of all the sides remain the same. Let me go and erase that. So what does that mean? Well, if I want this to be 1, I could think of like, all right, divide everything by square root of 2 then, right? I'm going to compress this triangle down to a smaller triangle where we get 1 here. So if I have the hypotenuse as 1, what I did is I created this ratio of dividing each side by square root of 2. So square root of 2 over square root of 2 is 1. Well, 1 over square root of 2, right, that's not rationalized, so typically we rationalize it by multiplying by root 2 over root 2, and we get root 2 over 2. Well, that's both of these sides, right, because they're the same. They both were 1, now they're both root 2 over 2. So where does that come in play on this unit circle? It's because notice the x value down here is now square root of 2 over 2, right? Which means that. But the y value is also square root of 2 over 2. And in fact, no matter where you put this special triangle, the 45-degree angle, you're going to have the x and the y square root of 2 over 2. But think about the quadrant you are in. I'm in quadrant 2 over here, right? All the x's are negative in the left quadrant, right? I went back square root of 2 over 2. I went negative square root of 2 over 2 for my x. So therefore, x is negative. Think about quadrant 3 here. Right now, I'm right here because I'm at the fourth, right? 5 pi over 4. It's still, again, square root of 2 over 2. But in quadrant 3, everything is negative. X is negative, y is negative. I went back square root of 2 over 2, and I went down square root of 2 over 2. They're both negative. And last, at the 7 pi over 4 right here, right, I'm looking at all of my 8 pieces of pi, right, split it into fourths. Again, square root of 2 over 2 for x and y. But I went right, so x is positive, y is negative because I went down. Okay, that takes care of all of the angles here that have 45 degrees. So now we're going to look at all these points with the 30s. Okay, whoops. Actually, yeah, let's go ahead and do like how about light blue? Alrighty. So similar thinking here. If I were to draw this triangle 30 degrees, here's my right angle, right? And compare that to this over here. Here's my 30. So therefore up here's my 60. And here's my 90. But I need this to be 1. Right? So I'm scaling it down half the size, because I need the radius to be 1 since I'm on the unit circle. Well, again, there's ratios, right? So just take this 2 divided by 2. So therefore, take every side divided by 2. Square root of 3 divided by 2. And 1 divided by 2. Again, we could picture this light blue triangle over here. And that means the x value is square root of 3 over 2. Right? So the x value is that. The y value is 1/2. I went up 1/2. All right. And now similarly for the 60, but really all we did is we took this triangle, right? This triangle I have, and I spun it, because the 60 is down here. So therefore, if I spin this thing, right, the 1/2 is here. Here's my radius of 1 and square root of 3 over 2. So all that did is change the x and the y. Okay, and that's an easy trick for all of these. They all, notice, either have square root of 3 over 2 or a 1/2. Every coordinate on this unit circle that has a 30-degree reference or 60 will be 1/2 or square root of 3 over 2. Here's how to make this easy. Okay, if you pull up the unit circle online, it's overwhelming. But notice the x value is smaller than the y value here, right? Because I only go back just a little bit, but I go up a lot. So therefore, 1/2 is less than square root of 3 over 2. So x should be the 1/2. And then just like before, think, all right, we're in quadrant 2, right? X is negative. So make the x negative. This point, it's going to be reverse of that one. The x and the y change. So it's negative square root of 3 over 2, positive 1/2, right? Back square root of 3 over 2, up 1/2. And then you could use symmetry and reflections and like all of these. Filling in the rest is really easy from here. Like notice this was 1/2 square root of 3 over 2. It reflected over y, right? So the point is the same, except for the x becomes negative. If you compare this one here with 5 pi over 6, same thing but negative. Well, if I reflect over the x-axis, then what changes? The y value, right? I went from a positive 1/2 to a negative 1/2, but the x didn't change at all. Oh, I ran out of room there, but that is a point. Okay. No. All right, likewise down here, I mean, a few ways to look at it. One, I know, like, just reverse these two. So I get negative 1/2 negative root 3 over 2. Or I can look at the point above it, right, up here, and know that I flipped down here. So all I did is change the y to a negative. And you could kind of use that same reasoning over here, right? Look at this point, it reflects over the y-axis, which means this is a positive 1/2 negative root 3 over 2. And then flip these two, so we get a square root of 3 over 2 positive, because we're in quadrant 4, right? To the right square root of 3 over 2, down 1/2. All right, that's one trick. just remembering the special triangles and how they fit in here. The last thing to kind of get you going, I wanted to include this. Sine we're going to learn on the unit circle is the same as the y value, cosine is the x on the unit circle. Okay, otherwise we have to divide by r. We'll learn that later, but in this case r is 1, so that's why we just say y and x. Okay. Alright, if sine is y, here's another trick. Sometimes I'll just use this table and then go to the unit circle from there. The trick is this. You do square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, all over 2. So why did I write it like that? Like square root of 0 is 0, right? I only did that because it's a trick to memorize it. Notice like square root of 2 over 2, that can't reduce. Square root of 3 over 2, that can't reduce. So if you use this trick, square root of 0, 1, 2, 3, 4, everything over 2, and then simplify it, you have all your unit circle values. Right? This is 0. Square root of 1 is 1. Square root of 2, I can't do anything. Square root of 3, I can't do anything. This becomes square root of 4, which is 2. 2 over 2 is 1. Okay, I'll highlight now. Sine is y. 0, 0. 1/2, 1/2. Square root of 2 over 2, square root of 2 over 2. Square root of 3 over 2, square root of 3 over 2. 1, 1. All right. Well, how do we get x? Easy. Reverse it. If I have all these simplified values, right? I'm going to go backwards. So cosine starts at 1, ends at 0. Right? I'm moving this one here. And then it goes square root of 3 over 2. And then it goes square root of 2 over 2. And then it goes 1/2. And then it goes 0. All right. Let's pull up a different highlight color. Orange. X. Okay, I'm starting at x. I'm starting at 0 degrees. 1, 1. Square root of 3 over 2. Square root of 3 over 2. Square root of 2 over 2. Square root of 2 over 2. 1/2. 1/2. 0, 0. Once you have quadrant 1, remember it all becomes just a matter of changing the x's and y's and making them positive or negative, depending on the quadrant. Okay, this trick, actually I had a student show me this. I've never seen this before. This was way cool. Okay, I could take that and recreate that unit circle in seconds. Okay, hope this helps. It's overwhelming, right? Look at that unit circle. It's overwhelming, but break it down. Remember your values or use this little table trick.